Okay, my dear students, you have entered this particular program now. Somebody is talking. Who is Praveen? Don't talk, please. Who is Kalyan Koppaka? Who is Kalyan Koppaka? You people are entering with registered names. We have already asked you to enter the classwork via your registered numbers. But still, most of the people are entering with their names. So this is somewhat difficult for us to collect the attendance. I request you to enter the waiting room or the classwork, whatever it may be, the Zoom meeting through this particular your register numbers. Now, for unit 1 is over. That is nothing but the operations research. The second chapter is transportation problem. This is unit 2, and compared to the previous chapter, this is somewhat easy. And again, we have another class at 3 o'clock. So still some people are entering. A very big nuisance for me. Introduction, the transportation problem is one of the subclasses of the linear programming problems, in which the objective is to transport various quantities of a single homogeneous commodity that are initially stored at various origins to different destinations. In such a way that the total transportation cost should be minimum. So there are various goods are going to be there, and all these goods are to be transported from different locations to different locations, or one location to the different locations. In such a case, you have to analyze the transportation cost. If you adopt a particular method for transportation of the goods, it will incur you certain cost for the transportation of the goods. Whereas if you adopt some other method, automatically it may reduce your the cost of transportation. So similarly, what are the different methods that are available, and how can we minimize this particular transportation cost? So that is the topic of this particular gist of the particular syllabus.
మా సిఆర్రెడ్డి కాలేజ్ లో అందరూ హెచ్ఓడిఎస్ రూమ్స్ లో ఏసీలు ఉంటాయి, అందరు రూమ్స్ బాగుంటాయి, కానీ మా మెకానికల్ తప్ప
328
వస్తాడు, కానీ మా వాడు ఇంకా
328.
Hello, who is Pradeep
Regular.
Kumar? Pradeep Kumar and Dani, don't talk please.
3.
Who is Pradeep Kumar? Don't shout. So the transportation problem is one of the subclasses of the linear programming problems. So in this, in the previous class, we have discussed about graphical methods, simplex method, big M method, and finally two-phase method. So there is every distinction is there from one method to another method. So now this is a transportation problem. Here there is an example. A shoe company which has in a different manufacturing units located at different places of India, the total products are to be transported to n retail shop in n different places of India. So similar case for cold drink company. So this is the problem for this. So if you take up a particular shoe company or a brand, it will have different locations. If a particular company started at Delhi or something like that, it cannot transport all the products to a far away place. So therefore, it is a usual practice to start a different start the different company units at various places of India. Depends on the geographical region of the transportation. Similarly, a shoe company which has different manufacturing units. One will be in Assam, one will be in Kerala, or one will be in Delhi, one will be in Jammu and Kashmir, like that. Located at different places of India, the total products are to be transported to n retail shops, n different places. So this is similarly the case for cool drinks company also. A transportation table is used to solve the transportation problem as seen below, like the simplex to solve the LPP problem. So here you can see this is a particular table. So this is D1, D2 destination. D1 means destination 1, destination 2, destination 3, destination 4, destination 5, like the destinations, number of destinations. Next here, this is location, first location, O1, O2, O3, O4, ON, like that. So this is a C11, C12, C13, like that. These are the cost of transportation from this point to this point. So this is the cost of the transportation. From this point to the last one, is the cost of transportation will be marked here. So like this, these are the different tabular forms. So this is transportation table. This is going to be a transportation table. And finally, what are the total? This is the demand or destination. And finally, what are the total components that has reached this particular thing? And finally, if it's horizontal, what is the total destinations that is reached at the end of the particular thing? Next, the various RNs and destination requirements are presented in figure 7.7, 7.1. The necessary and sufficient condition for the existence of a feasible solution to the problem is B1 plus B2 plus B3 B to the n is equal to A1 plus A2 plus A3 up to AM. That is total requirements is equal to total availability. Total requirements. So this is the availability and these are the requirements. So the requirements and this is the availability they should meet. So that is the basic condition. So if availability and the requirement should not meet, then therefore you have to extend this particular table either this way or in the downward fashion. So that is a dummy cells are to be created so that you can understand while solving a particular problem. So matrix form of transportation problem. So this is minimize z is equal to Cx, where Cx to the power of t, that is implies r to the power of mn. So subject to the constraints, there is something has given. You need not bother about all these things. This is a theoretical part. It should be noted that the elements of A are either 0 or plus 1. For a transportation problem involving 2 origin or 3 estimations, m is equal to 2. The matrix is given by, so like this. So A is given by, he has given 2 origins and 3 estimations. So matrix form transportation, form of the transportation is not practical importance. Transportation table moving towards optimality. The first step is to obtain initial basic feasible solution. With the second step, move towards optimality. So the initial basic feasible solution and what indicates the various methods used in this. Various methods used to obtain the initial basic feasible solution are: one is northwest corner rule, second one is row minimum method, Third one is column minima method. And fourth one, matrix minima method. And fifth one is Worzel's approximation method. There are 5 methods are there to solve this particular transportation problem. This is very important. And in the examination, you will be given a particular problem and you will be allowed to solve. You will be asked to solve by at least 3 methods or sometimes 2 methods. And you will be asked to identify what is the best maximum optimum method. So in such a case, the first one is northwest corner rule, row minima method, column minima method, matrix minima method, Worzel's approximation method. So in the northwest corner rule, in this method, the first assignment is made in the cell. It's not in the cell occupying the upper left hand. Upper left hand means top left corner. So that is the northwest corner of the transportation table. There is a sample problem will clarify this method, your method or rule. Determine the initial basic feasible solution to the following transportation problem. So whenever this northwest corner problem is given, first of all, you would assign the first to the top left northwest corner, and therefore then from that you have to climb down to identify the different things. Here this is O1, O2, O3 and D1, D2, D3 are destinations, orients. So these are the orients, these are the destinations. 6415 is there, 8927 are there, and 4362 are there. So this is the cost of transportation, you can call it as cost of transportation, cost of transportation. O1 to D2, it is cost of transportation. O1 to D3 is the cost of transportation. And so like this, these are the. And here it is nothing but the demand and requirement. 6, 10, 15, 14 are the requirements. So whenever it is given, you have to calculate this. What is the sum of this and what is the horizontal sum of this? So it should balance. Feasible solution exists if the sum of the availability is equal to the sum of the requirements. 14 plus 15 plus 5 is equal to 35. And similarly, 6 plus 10 plus 15 plus 4 is equal to 35. Now the entire matrix is balanced. So the requirements and supply both are the same. Hence, you can proceed for the particular problem. So if there is a deficiency, then you have to add either column or row, depends on that, to balance the particular matrix. So that is a different case. You will encounter that particular problem in the next table. Now this 6415 and 8927 and 4362 and all these things are nothing but you have to rewrite the table. Now that after assuming this, after checking this particular initial fees condition, and you have to rewrite. Applying the northwest corner rule. Now this is the first corner we have to allocate. The first corner, here 6 is there, here 14 is there horizontally. If you go to this particular thing, you can allot only 6 here. You can allot only 6 here because it is 6. And if you allot 6, what is the balance here? 14 minus 6. It will be there, 8 will be there. So you leave it like that. So 6 is allotted. Next comes to, you come down like this. Next you come down onto this particular point. Here how much it is? He has come like this, 6 plus. So how much you can allot? Here how much left is there? It is 8 till is left there. So here 6 was allotted here. 6 was allotted here. Finally 8 is left here. So that 8 he has allocated. He cannot allocate 10 here because 8 is only left to balance this particular row. 8 you allocate here. So if 8 is allocated and balance is nothing but 2, it can be allocated like this. So 2 can be allocated like this, and 2 means if you allocated 2, what is the left here? 14 will be left. So 14 will be left. Next, in this particular case, he has allocated almost 14. So 14 plus 2, so therefore totally it is balancing 16. So finally, if you come down to this particular one, so if you adopt 1, so 14 plus 1, it is becoming 15, column is satisfied. And after that, if you come like this, 1 is added, finally you have to add 4 here. So 4 plus 1, finally it is 5. So like that, this is the northwest corner rule. First of all, he has allocated the top corner, empty corner 6 here, and 6 is balanced. And if you come across, finally 8 is left. So 14 minus 6 means 8 is left, and 8 he has kept here. So if you come across this to balance this vertical column, 2 was allocated here. If 2 is allocated, 14 is left, and he has allocated 14. Why? Because there is a 15 is there, 14 is there. So 14 is allocated. So finally 15 is there. For this you can allocate only 1, and 14 plus 1, it is 15 and satisfied. So it is 1 is allocated means, so finally you have to apply, allocate 4 only. 4 plus 1, 5. This is row wise, column wise, both are to be satisfied. If you come across, check the table. 6 plus 8, 14. 2 plus 14, 16. And 1 plus 5, 1 plus 4, 5 is 5. So vertically 6, 10, and 15, and 4. So this is the northwest corner rule. Now you adopt this particular thing. These are the things. Next comes to, it has been proved theoretically that a feasible solution is obtained by northwest corner rule or by other method is a basic feasible solution. So generally what, so this is the way we can conclude the particular thing. Next, there is a row minimum method. Row minimum means he has given a particular problem. This is the first column, and this is the first row, first column, all these things. So this is 4 plus 2 plus 2, it is given. Total it is 8. It is also 8. Total it is balanced. Requirements and availabilities are balanced here. Now this is a 50, 30, 220, and 90, 45, 170. So here row minimum method, in the first row, what is the minimum? 30. So 30 means for 30, because 30 is the minimum in the first row, hence it was allocated 1. So 1 is horizontally, it is balanced. 1 is allocated. So vertically, you can allocate only 1 here. Next, vertically. So next comes to again row minimum. In this row minimum, again 45 is the minimum. You can allocate, how much you can allocate? Already you have allocated 1 here. Only you can allocate 1 here, and automatically it will become 2. Vertically it is satisfied. So that is 1 and 1. What is that? So satisfied. Next comes to, so here to make this balance, the next 90, this is along the row minimum, 90 will be the next minimum. So for that he has allocated 2 plus 1 here, totally 3 balanced. Next comes to in the third row is over. This is over. In the last one, it is 250, 250. So how much he can allocate here? He can allocate only 22 here. If 2 is allocated, next one is also 2. Therefore, totally 4 is balanced. 4 is balanced. But one has to see that. Here 1 is there, 2 is there, means finally 2 totally. Here already 1 is there, 2 is there already, 2 is there. So therefore, if you allocated 2, and this is the next minimum, next if you allocated 2, and horizontally it is being balanced, and vertically it is also being balanced. So 2 plus 2, 4, and 1, 1, 2, 2, totally you are, this is 4 means like a 2, and this is nothing but a 2, and vertically it is 2 here, it is 1 here. So 2 plus 1, 3 balanced. 1 is horizontally balanced. 1 plus how much it is? 1. Vertically 2 is balanced. So similarly, in the third row, 50 is the minimum. 2 you can adopt here, whereas you cannot you cannot adopt anything. Already it was balanced. So it is 1 is there, here 1 is there, here 2 is there. 1, 1, 2 balanced. Oh, finally this corner is on left. You can add 2 here, 2 plus 2, vertically 4 is balanced. And here 2, and here 2, totally horizontally balanced. Here 2 is there, 1 is there, 3 is balanced, and 1 is there, horizontally, it is also balanced. So this is row minima. In the first row, 30 is the minimum. Hence, first of all, you can allocate for one row. So the 1 is balanced, you can remove this. In the next row, 45 is the minimum. You can allocate how much you can allocate here. 1 was already allocated. You can only allocate 1, and vertically it is balanced. You can remove this particular thing. Next one, so this is in the next row, this is the row is left. So among 90 and 170, 90 is the minimum. You can allocate 2 here, 2 plus 1, totally 3 balance. And finally, third row, 50 is the row minimum, and 2 can allocate, vertically it is balanced. So for horizontal balancing, you would add 2. So like that, a row minimum has to be calculated. Now transportation cost is equal to, so all these elements, all these are nothing but the costs. All these costs are to be marked in the particular table. So there is no cost here, one cost, two cost, two cost, and again this is two costs. So here 30 into 1, 90 into 2, 45 into 1, 250 into 2, and 50 into 2. Like that, you have to calculate. So this is 1 into 30. This is 2 into 90, not 80. 1 into 45, 1 into 45. So 1 into 45, 2 into 90. Next, this is 2 into 250. 2 into 250 and 2 into 50. Last thing. So 855 rupees. So this is the total transportation cost. So actually, all these costs are to be clearly marked here. All these costs are to be clearly marked at this particular corner. One here in this corner, 2 here, 2 here, 2 here, and thereby you have to multiply and calculate the particular things. So that is row minimum method. Row minimum method. Is 357 with 357. 357. Next comes to column minimum method. In the column minimum method, it is similar to row minimum method. In the column minimum method is also, it's nothing but similar to the row minimum. In the vertical column, what is the minimum? 50 is the minimum. You allocate first. How much you can allocate? Only 1 you can allocate. So next comes to, this is balanced automatically, 1 and 1. Next, second column, this is 30, 45. What is the minimum in this particular thing? 30 is the minimum. You cannot allocate anything because it is already balanced. So therefore, is 45 is the minimum. You can allocate 2 here. Sorry, it is also you can allocate 1 only. So 1 here, totally 2 balance. Next, third column, what is the minimum? Here 50. You can allocate 2 so that vertically balanced. So vertically balanced means after you remove this particular thing. Again, go for this next row, next column. Already it was allocated. So you go for this next minimum. This is 2 is the minimum. Like that you have to balance. So next column, what is the least? 200 is the least. Already 30, 1 is allocated, 45, 1 is allocated. This, there is no possibility. And the third, again, what is this thing? Is already 170 is there. 170, you cannot put anything. So again, if you go to this again, third time, if 50 is there, 50 is over, 90 is over. So 2 you can allocate only. Here 2 was allocated to balance this particular thing. So like that, it will also give the same column minimum method. Next, a matrix minimum method. One should be very careful. So unless you solve the particular problem, it is very difficult. So origins and destinations 1, 2, 3, 4, 4, 3, 2, 0, 0, 2, 2, 2, 1, and 6, 8, 10, 24 is balanced. 4, 6, 8, 6 balanced. Matrix minima, entire matrix, in the entire matrix, what is the minima? So here you can see that. So 0 is there. Generally, 0 cannot be considered as minimum. So here he has considered there are two minimums. This is 0, this is 0. In some books, it is not marked as minimum. Only one is going to be marked. So for this, there are two zeros means, again, if you go to this, the total balance is nothing but a 4 here. The total balance is nothing but 8 here. In such a case, you have to go for adopt this first 4, first 0, first low minimum. So here 1 is there, 1 is there. Among this, you have to choose only 1. Here it is also 6, and it is also 6. And if it is again goes to horizontally, it is becoming 10. So what is the minimum means this should be taken. So minimum 4, minimum 6. Here minimum 6 and maximum minimum 10 here. In such a case, you have to adopt this particular one. What is the minimum allocations and destinations? Now he has taken this particular 0, this particular 0. So first he has taken this particular 0, allocated 4, and vertically it is balanced, vertically balanced. And if it is to be balanced, finally 6 is left. You have to mark 6 here. You round up, mark 6 here. So 10 minus 4 means 6. So remove this entire vertical column. Remove this entire vertical column. So while working on the board, I used to cut down this particular column, then you can understand. So next thing is nothing but this is the particular thing. So there is 8 is there, 6 is there. So hence 6 is what the minimum means, 6 is allocated here. If 6 is allocated, you are left with the 2 here. You are left with the 2, cross this particular column. Okay, next comes to what is the minimum? Because this column is crossed, this column is also crossed. This, you are left with only 2 columns. 2 columns means these are the 2 columns. So in these 2 columns, what are the elements that are least? 2 is there, 2 is there, 2 is there. So there are totally 4 2s are there. 4 2s means if you go through this horizontally, and among these 2 is the minimum, he has allocated 6 here. So 2 is the minimum in the entire matrix, and but unfortunately 1, 2, 3, 4, 4 2s are coming. So if you adopt this particular 2 and 6 is balanced, 6 is balanced vertically. So what about this 6? If you adopt 2, you cannot put 6 here. This is wrong. Next comes to 6 is balanced completely. 6 is also balanced completely. And if you remove this horizontally, and if you remove this vertically, finally you are left with this vertical column. So in this vertical column, what you can adopt, this for 2, you cannot adopt anything. Still there is 2 is there. So 2 means you can adopt 2 here. And similarly, this is vertically, 8 is there. So if you adopt 6, 6 plus 2 totally, it will become 8, it is 2. So like that, you see this, 6 plus 0, it is not 6 here. It is 6 plus 0, 6 vertically balanced and 6 horizontally balanced. This is 0 vertically balanced. This is among all the things. So why I have chosen this means because vertically it is 6, horizontally is also 6. So like that we have gone for this. It is balanced totally. Next there are 3, 2. This is the vertical column that is left. 3, 2 vertical column this is 2. This is 2. For that 2 plus already 6 is there. If we adopt 2, totally it becomes 8. And similarly, vertically it is also 2 plus 6, 8. So like that, all the elements are balanced. All the allocations are balanced. 4, 6, 2, 6, 6, like this allocated. So all these things are to be marked in this particular column. So this corner, the problem is there is some not the correct method. So this 1 should be in this particular corner, 2 should be in this particular corner, 3 should be in this particular corner, 4 should be in this particular corner. The allocations, what are the allocations we have made? That allocations are to be marked here. That allocations are to be marked here, and therefore this is if you mark that the concerned things. So the 6 is allocated. 6 means 6 into 2. So 6 into 2, next to 2 into 2, 6 into 0, 4 into 0, 0 into 2, plus 6 into 2. So like that, totally 28 is the answer, transportation cost, total transportation cost. This is the total transportation cost. All these allocations, this 6, this is 6, this 0, and all these to be, all these to be, are to be marked in these particular corners. At this particular corner, and this particular corner, and this particular corner, for all the corners. So right hand downside corner, the allocations are to be marked. The allocations are to be marked. So after that, now this 6 into 2 totally 12. So the 0 into 2 that has to be marked, that has to be shown here, 0 into 2. 4 into 0, 6 into 0, like that, all these things are to be marked, and you have to calculate the transportation cost. It is to make you understand there is some difficulty unless you have the particular board, all those things. So if you open the Paneerselvam book, it is very big clear. The allocations are very clear. So in this somewhat clumsy and confusing. So in all the things, so what you have to do, matrix minima method. Matrix minimum means among the entire matrix, what is the minimum element that you have to identify. For that, you have to give the first allocation, and thereby you have to balance either vertical column or the horizontal row. So if that vertical column is balanced and you have to remove that particular thing, you have to cross. You can repeat the table. Among that repeated table, again, what is the minimum element in the particular matrix? Again, so this 0 is so this 0 means first it is balanced. After that, the second one row is nothing but the vertical column. First one, it is balanced. You remove this and you put here 6 here, and you are left with these 3 into 3 matrix. Among the 3 into 3, what is the least? 0 is the least. You allocate what you can allocate vertically, 6 you can allocate, still you are left with the 2 here. So he has allocated 2, but he has not crossed here. So next to the remain left 2, 3, 3, 2, 2, 2, 2, 3, 3, 2, 2, 2. So like that, the concerned things are also going to be balanced and therefore to be allocated. So when 2, 3, 2, 3, 2, 2, all these are nothing but the least elements. 2, 2, 2, 2. So depends on the convenience of balance. Depends on the convenience of balance. Here 2, 3 is there, finally 6 is left. Among the things, 2 is the minimum. And next 3, 2 is there. So among 3, 2, 2 is the least, but you can allocate, already 6 is allocated in this particular case. So already it is over, 6 already balanced. So next 2, 2 are there. Horizontally you have to check, vertically you have to check and balance and see that elements are allocated, cost is calculated. Next comes to the Vogel's approximation method. Vogel's approximation method. This is very important. The Vogel's approximation method, the cost of transportation is going to be much minimum, and Vogel's approximation method is going to be called as the best method, best transportation method. Or else sometimes it is also going to be called as penalty method. Now we have seen one is northwest corner rule. Second one is row minimum. Next one is column minimum. So you have to identify row minimum. First row minimum, allocate, delete it. Second row minimum, allocate it, delete it. Third row minimum, allocate and delete it. Similarly, column minimum. First column, second column, third column. In the first column, what is the least element? Allocate and cross the concerned column or row. And next, second column, you allocate, balance it, remove it. Remove the either concerned vertical column or row. So like that, column minimum and row minimum. If you understand the row minimum, automatically column minimum can be understood. Next, matrix minimum. Matrix means if you are given a 3 into 3 matrix or 4 into 4 matrix or 3 into 4 matrix, whatever it may be, you have to identify what is the minima in the particular matrix. Therefore, you have to allocate the either demand or availability. And after that, you have to remove either cross the vertical column or cross the horizontal column. Rewrite the table. Again, identify the least. What is the least element? Least element among the matrix, among the left out matrix. So therefore, allocate the minimum, identify the minimum element, allocate, and finally either cross horizontally row or vertical row. Automatically you will get the thing. Now this Vogel's approximation method is a very, very important method. In the examination, you will be asked to solve this particular thing. You will be given a particular problem. You will be required to solve northwest corner rule and matrix minimum method and Vogel's approximation method. Solve the following transportation problem with the following 3 methods and identify suggest which method is best for the transportation. Like that, the question is going to be there. So therefore, you have to adopt all these problems, all these transportation problems and solve them. Here, Vogel's approximation method or penalty method, obtain the initial basic feasible solution using Vogel's approximation method. 513333. These are the cells and the availabilities and demands and balances. Availability, demand. So you have to check whether it is balancing or not. If it is not a balanced, unbalanced transportation problem, it becomes. If it is an unbalanced transportation problem, you cannot solve it. So therefore, you can solve it by balancing it. Before you start, you have to balance it by adding an extra column or by adding extra row by giving dummy variables and concerned cost. So this is 5133, all these things. So you check this first row. In the first row, what is the minimum? First minimum, second minimum. First minimum, second minimum. First minimum is this, second minimum is this. And here, what is the first minimum? 3. Next minimum is nothing but 4. Yes, marked it as 0. 3 and 3, first minimum, second minimum, they cannot be this thing. The problem is wrong. You better refer S.C. Sharma or something like that. So here 1 and 3 is there, therefore difference is 2. This 2 is going to be called as penalty. So here 3 minus 3 is marked 0. And again, yes, 4 minus 4 again is marked, it will be 0. So here first minimum 3, second minimum 4, difference is nothing but 1 here. Instead of 0, you mark 1. Next, first minimum is 3, second minimum is 4. 4 minus 3, 1. So this is, you see 34, 15, 12, 19, they will remain as usual. So the brackets, the elements that are shown in the brackets are nothing but the penalties, are nothing but the difference between the first minimum and second minimum. So this is the first minimum and third is the second minimum among the entire row. So 3 minus 1, it is nothing but 2. So 3, 4. 4 minus 3, it is nothing but 1 here. It is 4 minus 3, it is nothing but 1 here. First minimum, second minimum. Next comes to, you see that minus 1 is there here. Minus 1 means first minimum, second minimum. 2 minus of minus 1, it becomes 3. 2 minus of minus 1. First minimum, second minimum. Second minimum minus first minimum. Second minimum 2 minus of minus 1, it is becoming 3. So vertically this is 5, 3, 6, 4. 5, 3, 6, 4 means, again he has doing a big mistake. 4 minus 3, it is nothing but 1. 4 minus 3 is nothing but 1. Next year, 1 minus of minus 1, it is 2. 1 first minimum, this is least, next minimum. So minus 1 minus of minus 1. Here it is 4 minus 3, it is 1. First minimum, second minimum. 4 minus 3, it is 1. Next year, 3 minus 2, it is 1 here. He has put some 0, something like that. So after this, what you have to do? You have to allocate among all the elements what is the least. The 1 here, 1 here, 3 here. Again, this is also 1. This is also 1. All these things. So the penalty method means so this is 19, nothing but this is minus 1 here, 2, 3. So among all the, what is the maximum difference? 3 is the maximum difference. 3 is the maximum difference means, so if you go to 3 horizontally and observe what is the least cost. What is the least cost means minus 1 is the least cost you allocate to this particular thing. 19 is allocated. And the balance 25 minus 19, how much? It is nothing but 6 mark. 6 is marked here. 6 is marked here. So horizontally, among all the penalties, 3 is the maximum penalty. So in this, for this maximum penalty, if you go horizontally, what is the least cost? Minus 1 is the least cost to allocate maximum. And here 19 is there. And you can allocate 19. Remaining 25 minus 19 is nothing but 6 is marked here. So this entire row is going to be cancelled. Entire row is going to be cancelled. So in the next case, 5, 3, 6, 5, 3, 6 are there. 4 is not there. 5, 3, 6, 21. And 1, 3, 4, it is nothing but 6. Because 25 minus 19, this is 6 only. Next, this is 3, 5, 4. 4 will not be there. It is 17 as usual. 3, 4, 3 as usual. 17. After that, again, you have to identify what is the first minimum and second minimum. 3 minus 1, it is 2. And 5 minus 4, so 3 minus 4, it is 1. And again, 4 minus 3, it is 1. Again, 4 minus 3, it is 1 here only. And 5 minus 4 minus 3, 1 here. And 4 minus 3, 3 minus 1 is 2 here. It is also 2 here. Again, among all the things, 2, 2, 2, there are so many 2's are there. So which 2 has to be adopted means, so here you have to go for the maximum. that is a maximum 34 value. So 34 value for that he has adopted. So among again horizontally, if you check up how much you can allocate out of the particular thing vertically or horizontally. So this is the this is the 34. Sorry, what is the difference between these two twos are there? No, so many twos are there. But out of that, only you can select one. The value is maximum is there. For that maximum, if you go to the horizontal, you can allocate 6 here. 34 you cannot allocate because this 6 has to be balanced. 6 has to be balanced. So 19 and 6 is balanced. 19 and 6 is balanced. So then the next iteration, 1 is going to remove this entire vertical column. This row is removed, column is removed, and here 34 minus 6. So therefore it is 28 it is left. 28 is left, 5, 3, 3, 28. 3, 5, 4, 15. So 6, 4, 3, 12. And vertically it is this thing, 21. And this will not be there. So this will be there, this will be there. So you see that that is nothing but 19 and 6 are allocated. He has removed. Horizontally, this is also removed. And finally, it is 28, 15, 12. And this is also 5, 3, 3, 3, 5, 4, 3, 4, 3. So all these things are marked. Again, among all the elements, you go for the 3 minus 5, first minimum, second minimum, and difference is nothing but 2. In this first minimum, difference is nothing but 1. So the 4 minus 3 it is nothing but 1. Again, 4 minus 3 it is nothing but 1. He has marked 0. It's not correct. You check with other books. So here horizontally 3 minus 3 0 he has put, and 5 minus 3 minus 4 it is 1. 4 minus 3 it is 1. So among all the penalties, again 2 is the highest. So 2 is the highest. If we go vertically, and the least element is nothing but 3. And if you go horizontally, 15 you can allocate here. 15 you can allocate. Finally, 21 minus 15, 6 will be there. So and 6 is marked here. 15 is marked here. And the column will remain, but because 15 is balanced, this is going to be removed. This is going to be removed completely. One vertical column, the one vertical column are left. These are the two vertical columns that are left. So, in the two vertical, so one vertical column, and this is a one vertical column, and the second vertical column. So finally, they are left with. So 15 means finally 6 is left here. So 6 and 17 automatically they have to be balanced. So 6 means already 12 means totally. It is so 15 is there and 12 is there. Finally, he has written down the problem, entire problem, and marked it. So 6 was allocated, and this is not 12. This is going to be 6, and totally 12 is balanced. And so finally, it is 17. If you put 17 plus 6, it becomes. So previously it is 6 with are there. So you have to write down the separate column by removing this. The vertical column is remove this particular column. You remove this horizontal column. Repeat the entire table. Repeat the entire table means this column is there, this column is there, this column is there. The row will be there, row will be there, row will be there. So according to see that and see that again find out the differences, penalties, identify the penalties, then thereby if you allocate, and automatically problem is going to be solved. So here total cost is equal to 6 into 5, 15 into 3. Okay, here 6 into 1 horizontally, and 6 into 1, 5 into 3, 17 into 3. Next, after that, 15 into 3 and 12 into 4. 15 into 3, 12 into 4. 15 into 3, 12 into 4. And 19 into minus 1. So totally, like he has calculated, with the above technique, initial basic feasible solution is obtained. So the procedure can be explained by taking the following example. So this is another method. So it is somewhat difficult to explain for me. So 6846, this is the things and requirements, availabilities, both are going to be balanced. Is the first obtained by any of the 5 methods. Let us following the northwest corner rule initially. So in the northwest corner rule, 6 is there means first 6 it has to be balanced. After that it has come here. So 6 means 14 minus 6, 8 will be there. You can allocate 8 and you can allocate 2 here and you can allocate 14 here. So here 2 means 14 means totally 16 balanced. And if you come this 1, if you adopt 1, 15 is balanced. If you adopt 4, automatically 5 is balanced. So like that, we can calculate the particular thing. So in the examination, the problem will be, you will be asked to solve the entire problem by penalty method as well as northwest corner rule. So this is marked 6, 4, 2, 6, 4, sorry, 6, 8. 6, 8 means 14 horizontally. And the next one, 2, 14, it is 15, 16. 2 and 14 are there, 16. And next comes to 1 is there and 4 is there, totally it is 5. So like that, the dual variable UIVJ are first calculated for all the basic cells such that UIVJ is equal to AJ for all basic cells. These are calculated by using U1 is equal to 0 as presented in the following method, UIVA method. So this is a different method. You need not, this is not required for us. So this is, you can avoid this. So there are 5 methods. Out of the 5 methods, you will be asked to evaluate